Good afternoon, everyone, and welcome to this 1PLM webinar. I want to first start off by saying thank you very much for tuning in with us this afternoon. My name is Michael Smith. I'm from the 1PLM team. Over the next 30 to 45 minutes, we're going to take you through some content that we've really well planned, and we hope you find very interesting. It's actually going to be taken through by my colleague Mike Ashbow over in the Siemens team. But before we jump into that, I want to quickly run you through some of the regulations we're going to try and follow on this webinar, just to try and keep everything moving correctly. And the first thing I should state is there is a lot of attendees on the call, but we're very keen to still take live questions and we want to interact with you as much as we can. But to keep it clean, we've actually managed to take and actually set this up so you have the ability to ask us questions, but via a chat window or a question and answer window. If you can't see it on the right hand side of your screen already, please hover your cursor over the presentation section on the screen and click the icon. I believe it's the fifth icon along just after participants on the base of the screen, and you should see it pop onto the right hand side. You can use this chat window to communicate with us directly, privately throughout the call, or you can send messages to everybody, however you want to do it. But rest assured, we will try and answer as many questions as we can, and if we can't, we'll be in touch with you afterwards. I should also state that there's not actually a limit on how many questions you can ask. You can ask as many as you want and about anything, however diverse it may be, whether it's commercial, technical, and so on. We're more than happy to take any questions you may have, and we'll feedback afterwards, as I said. Now, on to the next section. I want to quickly give you a quick run through of who 1PLM are. Many of you probably already know this, but for anyone that doesn't, just so you know, we're a company that's been going for, well, over 20 years now, 23 years since 1997, in many shapes or forms. We're actually the amalgamation of three companies that have come together in the last 24 months or so. And we have a wealth of engineering experience, hundreds of years experience combined throughout our technical team. A majority of the company actually is technical. So we do definitely deem ourselves as technical specialists, and we like to think ourselves as being able to cover the Siemens PLM portfolio very well. We also offer a range of services, including technical support, consultancy, implementation and installation services, and so on. So not only do we supply the actual solutions themselves, but we also do support them technically from start to finish. And also, we're a company that's actually spread across the UK. We have an office in Liverpool, and we also have offices in Cranfield and Oxford. So we're geographically well based in the UK, and we continue to grow as a company as well. And we're very much looking forward to continuing this growth as time goes on and supporting more and more companies as time goes on. Now, you should also know that before the webinar starts, I should state that this is actually going to be recorded. So if you have your pens and pads ready, rest assured you don't have to keep up slide to slide. You are going to get a copy of this within the next week. We'll actually be able to edit the webinar as it is, clean it up a little bit and send it out to you within the next week. And you'll receive that via email from our team. And this is really just to package it up so you have it for reference later on. And feel free to use that webinar link to the recording to send to friends or colleagues that may be interested. Maybe they couldn't make it today, for example, but you want to send it to them, you're more than welcome to do that. Now, without further ado, I'm going to pass on to Mike, who's going to take you through the technical content, and I'll be back in touch at the end of the webinar just to give you some more 1PLM messaging and let you know how we can assist you with learning more about this module. Now, on to Mike. Thanks all.
Thank you very much, Michael, and it's really a pleasure to be here and participate in this webinar. We're going to be focusing on intelligent wiring diagrams. A little bit about me. I'm now with Siemens, a business development manager, focusing on our solid edge electrical products. And I actually came from Mentor Graphics, where I supported a lot of the electrical engineering tools. So I'm really happy to be here with you today. So here's what I have for an agenda. I want to talk a little bit about the key industry trends for electrical systems design. I think it's important to understand that, why we're meeting and speaking about that. And then introduce industry-leading technology that Siemens acquired from Mentor Graphics, which is a nice segue into the focus of the software today, which is solid edge wiring design. So I'm going to present an introduction and overview to give a framework for our discussion, and then spend most of our time together in the product demonstration. And as Michael said, please submit your questions through the chat. We'll make sure we follow up with a written correspondence to answer those questions. By the way, I'm broadcasting to you from the east coast of USA outside of Washington, D.C., and I realize a lot of people are working in remote environments now. So hopefully the broadband is working well. You can hear me clearly and see my video screen. So again, thank you for joining. So I want to begin with some industry trends here. And this is the results of a survey of engineering teams when they were asked about, for their products, what's the value now attributed to the electrical systems in those products? And the results was 71% said the value attributed to by the electrical system was increasing. And of that, 37% said that this increase was significant, right? So customers are building and filling this demand for these connected and customizable products. And this is making the products much more complex and the designs more challenging. So what's the impact of this increase in electronics? Well, the survey also said on the right-hand side, here's some of the new business pressures and engineering pressures experienced. There's a delay in time to market, for example. There's lost revenue, project budgets and overruns, design inefficiencies, perhaps poor quality, right? But there's a lot of impacts to this increase in this design complexity of our electrical systems. So for electrical system designs, right, companies recognize that in order to stay competitive, they're differentiating their products with these electronics and electrical systems. So they're adding more and more electronics. And there's a lot of reasons why the design is more complex. If we look on the left-hand side, there's just a number of compliance parameters that are associated with designs. There's laws in various countries and regions. You have additional requirements depending on the industry that they're in. There's rules, there's standards, governance, regulations. And all the while we have to follow those compliance, we have to show transparency that you're actually meeting this in order to sell your products into those industry sectors and regions. So there's really a big challenge. And what this boils down to is that engineering teams and companies are realizing that the traditional methods, they're just no longer working. So we need new methodologies to address this design complexity, and often requires new software. So that's the fundamental message of our discussion and focus here today. So to give you an example of what are some examples of smart connected products, here's some nice images to keep in mind. These are showing products that have harnesses inside of them. So the need to have wires that are bundled together and routed appropriately to meet the mechanical and electrical specifications. So this is a very good fit for solid edge wiring and harness design that we're talking about today. And as we said, companies are recognizing there's more and more electronics going into these products all the time, generation after generation of these particular products. Another good use for solid edge wiring design is in the industrial machinery. And here we're showing what that would look like, where this is also referred to as panel design or control panel design. In this case, the end users are not so much interested in doing the harnesses that need to be routed through an assembly, but what's very important for them there is to have that logical wiring diagram and the intelligence associated with it. So they know how these devices are connected together and do that very efficiently. So keep both of those in mind. Those are both very good fits for solid edge wiring design that we're talking about today. The leading industry technology. In 2017, Siemens acquired Mentor Graphics and picked up a lot of great technology. But for today's discussion, we want to focus on Capital, which is an enterprise-level electrical systems wiring and harness manufacturing. It's been targeted for decades for the aerospace and automobile industry. Leading industry technology, best in class. And the good news is for those of us that support the small and medium-sized businesses, this same software technology has been leveraged into the Solid Edge portfolio, and that new product name is called Solid Edge Wiring and Harness Design. So what you want to take away from this is that the software is the same, so it's not new software. Leading industry, very mature, lots of users, but it has been repackaged, rebranded for those that are doing working with Solid Edge or the smaller and medium-sized businesses. So the price point is much lower, you get access to the technology, and the implementation is simplified because there's less configuration associated with it. So it's really important to understand that where the software is coming from, the name is new at Siemens, but the technology is the core software from Capital, from Mentor Graphics. Now, where does this fit? When we say Solid Edge, it's essentially a portfolio. And what we're looking at here is the organization of this portfolio, which now contains over 55 products in addition to the core Solid Edge MCAD. We are showing here what's called pillars. And for the discussion today, where did Solid Edge Wiring and Harness Design land, that Capital technology? In the electrical design pillar. So this is what we're focusing on today within the Solid Edge portfolio. So with that as a background, let's just talk a little bit about the traditional approach when we talk about electrical systems design. What we see in this image, we have our electrical systems colleague on the right-hand side, where she is capturing her wiring diagram. We can see that on her monitor. On the left-hand side, we have our mechanical engineer working in his 3D environment. And the image shows this break in the image. And that's just underscoring the fact that they're typically working in isolated environments, and they don't really communicate back and forth regularly. And because of that, it's very difficult for them to be sharing the design data as they're going and developing this particular product. And the information exchange is very manual in nature and tedious. And that challenge actually gets pronounced more, especially if the electrical system is being captured in 2D drafting tools versus an intelligent wiring diagram. It really makes it difficult to share information. So what happens is they wait till the last minute to make the exchange of data, only to find out there's issues and constraints that they didn't have before. And it makes it very difficult to come up with the options to resolve these challenges. So that's the traditional approach. But there is a better way, and that's what we'll be talking about today. Bringing those two environments together where we can have this bi-directional communication so it makes exchanging of information real easy in real time. So we can do it at the very start of the product design and continue that through the entire cycle. So this is a good time now that I can introduce the software modules for Solid Edge wiring and harness design. So on the left-hand side here, I'm going to first introduce Solid Edge wiring design, far left. That's where users actually capture their wiring diagrams by selecting parts and symbols from an electrical parts library, which is part of the software. It's a centralized electrical parts library. As the wiring diagram is created, there's design rule checks that are running in real time to make sure electronically and electrically the diagram is sound and not violating various rules. Also, it supports simulation, where the circuitry could be analyzed to make sure the function is proper as we looking for the desired behavior. And we can also look at metrics like current and voltage to see that we have the wire size properly, for example. I'm going to show you that later in my demonstration. Now, tightly coupled to that is Solid Edge harness design. And if you're one of those customers at the end is to manufacture harnesses, you will be leveraging this piece of this software. The wiring design content, the connectivity is synchronized into the harness design. So that doesn't need to be recaptured. And then in the harness design, the user would add the physical pieces and elements that make up to develop and build this harness. That would be the clips, the grommets, the insulation, and things like that. All tied together nicely in one software installed and using wire design and harness design. So that's for our electrical systems colleagues. For the mechanical folks, they're shown on the right-hand side. They're in the Solid Edge MCAD. And what's important there, in order to share information back and forth with our electrical systems team, we need the Solid Edge electrical routing shown here. That enables to receive the wire content, have the ability to bundle them together in harness, route them within the 3D assembly, and then send the information back to the wiring design schematic so we have the proper wire lengths. This is what we're able to create with this integrated environment, bringing together the mechanical team with the electrical engineering team. So those are the names of the software that we'll be talking about today. So my focus is on the Solid Edge wiring design for this particular webinar as opposed to harness design. So we're just kind of taking the wiring design. Perhaps at another time we'll focus more on the harness design. So what I want to introduce and have you remember from this webinar is that Solid Edge wiring design will create intelligent diagrams. And you'll see what I mean by that. We're going to be building the diagrams by selecting symbols and parts from an electrical parts library to make sure the content we put in the diagram is correct. And you'll learn that we have features like styling, which enables you to have your company drawing standards followed by the entire team. It's automatic. It makes the schematics and diagrams easier to read and share with others. You'll learn too that there's design rule checks running in the software in the background to make sure we haven't violated some type of electronics check that are important to us. And then also there's simulation. So keep those in mind as we go through the webinar here. For the electrical parts library, there is a starter library that comes with the software. Currently, that starter library has over 4,000 symbols and parts. And this is where you do your component management. Now, your team will also add your own symbols and parts depending on the industry that you're in, the standards you want them to look like. But the main thing is that's the core underpinning of this software so that your team is selecting parts from the same centralized library. That's your golden IP to make sure that what you put on that schematic is correct. It has your company part numbers and any other information you want to have associated with that. There's electrical parts software utility to help you manage this. It's all part of Solid Edge wiring design. And what's important to understand here is there's relationships to the parts. So for example, when you put a device on your wiring diagram, that device has specific connectors that go to it. And those connectors have certain cavity groups and cavity properties. And it's very much aware of what terminals can go into those cavities. And for those terminals, what's the wire configurations that go in there? What's the maximum size of the wire? If I have more than one wire in there, what can that size be? All of those relationships are defined in the electrical parts library, which helps automate this entire process as you're capturing your wire diagram. And you know that you're with these checks going on as you're capturing design, that it'll be correct as you continue. It's very powerful. Sometimes you want to know if a part is obsolete or something like that. So with the electrical parts library, we can identify where else is this used? Are there other projects? And if so, what are those designs that are using this particular project? You can do those kind of things using this an intelligent wiring design application with this electrical parts library. Design rule checks as an example. There's several of them. They fall in categories such as appearance checks, connectivity, consistency, library consistency. I wanted to show one example here. If we look at the bottom of the image, it's actually showing 4 errors that it found or warnings. And the line highlighted in blue is it indicating that the wire that we have in our diagram is not going to fit into the cavity that we've selected. And so this check is going on in the background and identifies to us immediately, you got an issue here, you need to take a look at it. And the red text is a hypertext. I click on that and it brings us exactly into the drawing where this is actually the case, so helps us fix and clean that up. So that's an example of these design rule checks that go on for you. Circuit simulation, again, I'll show you this in the demonstration. Here we're looking at a part of an image within a circuit. And to point out here, we see the wires. There's wires in green and there's wires in cyan. The green are indicating that we do have a current flowing through that particular wire. And what we're able to do here is we can toggle the switch locations. So if I move the switch to position 2 from 1, will the current flow in the proper wires as we wanted our design intended? So that's an example of functional simulation. And the benefit of this is we don't have to add any special graphics on our display or a wire diagram in order to do this simulation. So it's really very efficient. If I point you to this image to the far right where it says wire 131, that is actually showing how we can measure the current and the voltage going through each wire. So that's really helpful for optimizing your design. Remember, we talked at the very beginning, right? Companies are under a lot of pressure to make their products stand out with electrical features, performance, quality, all of those compliance checks. This is a great tool to let you look at your design in this virtual environment and see if you're on track with the decisions you've made. Should you change the wire diameter, right? What's the impact of doing so? What's the impact to the mechanical design if we can use smaller diameter wires? So this is the tool that allows you to do that. Now, I'm going to talk a little bit about the data flow because I want to present the big picture of where you enter data and how it's shared, right, which is very powerful in the efficiencies. So to begin, right, in a wiring diagram application, again, we're going to be pulling the symbols and parts from the electrical parts library. And anytime you're ready to share that diagram with your MCAD team, we can share that information with what we call connected mode. Connected mode is a term we use at Siemens that references the ability of sharing data bidirectional between the electrical system tools and the MCAD tools. So if you look at the image now, we show the connected mode, where the electrical systems teams in solid edge wiring design bridge out data to the solid edge MCAD in the 3D environment. Now the 3D MCAD has the wire information and the connectivity that was created in the wiring design. Nothing had to be recaptured. There's no mistakes with translations. It's not manual in nature. So recall that traditional method where we had the isolated environments. We just bridged that gap, and now we're able to exchange data very conveniently. Our MCAD team would then bundle the wires together, route into a harness, route those as they need to meet their constraints, again, trying to optimize their design for space, weight, whatever that is. Once they're done, the length of the wires can now be shared back to the wiring design with a push of a button called Bridge In. And I'm going to show you this connected mode as part of my demo. Now with the Bridge In, the electrical system team has the actual lengths of the wires. And because we can do simulation, they can now look at this again and say, look, if these wire lengths have changed, if they're longer than what we assumed to be, will we still get the performance? Will that signal with the wire diagram we have designed now actually reach the receiver so that the signal is strong enough for the voltage? If it's not, we would run the risk that our behavior of our electrical systems would not work properly. So remember, our customers are recognizing that more and more electronics is added all the time. So this challenge only continues to grow. And here we're providing the ability to exchange this information easily and consistently. So for today's discussion, today's demo, this is the part that I'm going to focus on. But I'm going to complete the picture for you so you can look at the entire suite of solid edge wiring and harness design. So tightly coupled to this is solid edge harness design. And this big arrow in the middle is describing what we call synchronization. The wiring diagram information and connectivity gets synchronized with harness for those customers that need to create harnesses. So again, you don't have to recapture anything, but in the harness design application, now you can add the other physical pieces that you need to have this harness manufactured. And from there, all of the output documentation is automatically generated from what's captured in the harness design. And one final comment here about connected mode shown at the lower right-hand corner here. Some customers like to take the harness information that they have routed in their 3D MCAD environment and have that information go directly to harness design. And we use the term 2D flattening. That is also supported in this flow, and we call that bridge in because we're bridging in to the harness design from the MCAD. And that what's required for that is the connected mode. So again, as a reminder, the connected mode is the ability to share information bidirectionally between the electrical systems software and the solid edge MCAD. Okay, I'm going to get into the demonstration here and show you the solid edge wiring design. I'm going to assume everybody can see my screen properly. Okay, you're looking now at solid edge wiring design, full screen. And what I'm going to do first is just bring up a project that's somewhat completed and show you the anatomy of a project. How is the data organized? How do you find what you're looking for? And some of the outputs we can generate. And then I'll move on to show you how easy it is to create a new project, a simple little circuit, and run a simulation. So I'm going to open up a project here called Electrical Systems. Let's take a look at that. So I'm looking at a project browser here. The name of the project is called Electrical Systems. And in this project, I can have more than one design. And the designs are shown in the yellow folder. So I do have a design called Analysis. There's a design called Connected Mode, and so on, all the way down to wiring. I can also, each design can either be a wiring design or it could also be a harness design. Let me just show you what a harness design looks like. We won't go into more detail, but double click and I bring up the diagram for the harness design. And what we're looking at here is all the details, right, that are captured in order to build this harness if that's what you're going to do. If I zoom in here, these are all the cavity information for this particular connector. All this information comes from the electrical parts library, and we have everything we need. And from here, we can generate the documentation to actually have this harness built. So again, we'll save this for another webinar some other time, but that's the harness information. So let's go take a look at a wiring design here. This particular design called wiring is showing 10 various diagrams or sheets, all consistent with the same design. If I double click on number 7 here, this brings up that diagram that has been created and captured. What I first want to point out is once we open up a diagram, we now get the design browser shown at the left-hand side. The tool automatically organizes these subfolders in our design called wiring. So we have devices, connectors, inline, conductors, multi-cores. That's automatically created. And what the software does as you add elements onto your drawing, it puts those in the proper location so you can find them. This tool is very advanced. You got the middle mouse wheel and it supports strokes where you hold the middle mouse wheel down. Those of you that have used some high-end digital capture tools. It's very common in those tools there. When I select an element in the drawing here, notice that it also cross-probes with my design browser. And this is in the devices. Now you can see there's a long list of devices here. And that's because it's showing me all the devices in the entire design, which consist of 10 sheets here. If I go in here and I find something like this, I say, where is that? I can hit the Z and it'll go browse to that particular drawing where I can find that device and takes me right to it. So it opened up the drawing and found that for me. So it's a good way as your design grows in complexity to be able to find that. And what we know is all the properties associated with the device in here, we can change those properties, view those properties with right mouse button. And you can change the name here in the design browser, or you could change it in your contents window on the drawing. And you're going to see later on that this important field called library part, here's where we can do queries into our library, into the electrical parts library, and then add the parameters that are associated with the part. The other thing I want to show too is sometimes you just want to isolate the view for the active schematic. And we can do that by toggling this button down here. And now it's just going to show me the devices that are associated with this active schematic sheet here. So that's actually how that works, and we navigate through the project. The other thing here is, let me go to the styling here and point out that a little bit. Here's a wire. Again, all the elements on a drawing have properties. I can do a right mouse button, properties, and here's the color of the wire, the name of the wire, the material, or it even has a part, right? So you have all the details, and I can make changes here. If I wish, I can make changes in the design browser. But for styling, what I wanted to show was this wire may be in some other place in our drawing somewhere. In order for us to find out where that is, we can put on these off-sheet references. And this is an option that your team gets to pick. And in this case, if we're looking at this one and say view related items, it's showing us where else we could find that. So I could click on this and it would take me to that spot where I can actually find that other wire. And what we're looking at here, the syntax is what I wanted to point out. These are called off-sheet references. Your team gets to set these in the styling set. So what is the syntax you'd like to use to describe where we can find this wire? In this case, it says go to the drawing name. That's what the 07 power door locks are, for example. It has the component and the pin number that you can find it. And at the very end, the 3-D, that tells us in what quadrant within our title block we can find that. So if you wanted something shorter or different, you can do that all in what's called the style sets. And to find the style sets, I right mouse button after picking an element, I hit style, and I hit edit style. And it brings up this style set dialog, and it's highlighted in blue. Where can I find the details to actually change the name and the naming conventions? So this is where your team would decide how you want it to look. That's stored in the style set. And now anyone using the tool in your environment will have the same look and feel when it comes to creating the drawings. And that just makes them companies able to standardize, right, and make the designs readable. Okay, what's important here, I just want to say, once you've captured the details here, it's important that you know, how do you share this data with others that need it for field maintenance or something like that. One of the things we can do is take this data in the schematic and generate a PDF for it. There's a really easy print to file. I can set the scope. Do I want to generate the entire project? One of the designs within the project, I can pick all that. And then you have naming conventions. How do you want to name the files based on some of these smart parameters? Let me just click OK to just get this going quickly to show you that. And then in the output window down at the bottom, if I just double click the name, it'll bring up the PDF for me. And so here's my 10 sheets. I can browse just like I could in the design itself over here by picking this up and I can navigate through this. So this is pretty powerful. A lot of times people need a printout of their design because they need to share it with their team. And you can search this. For example, you can do Control F and hit search and go find quickly where these wire names are or a component or something like that. So let me just close the PDF real quick. And then another thing real quickly before we leave this project, under the drawing tabs, there's a number of tables that you can create. You can create a diagram list, a device list, a wire list. This, again, the benefit of intelligent wiring applications. All the content that you need is captured in the drawing. And then you have access to it through tables and lists. So device list, for example, automatically generated. I can place this list anywhere on a separate sheet, wherever I want. You went right to my cursor. I'm going to just zoom in so you can see this. This is actually a dynamic list, right? So if I change any device on my drawing, it will update this automatically. And to show you what I mean by that, let me do a simpler case here. This will show me the diagrams that we have in this design and the name of them. And for example, if I go to my diagram number 2 and I say, look, I want to edit this, and let's call it airbags 3, click OK, and now it updated that. So again, I wanted to emphasize that that's the benefit of intelligent wiring software, because you enter this in one place and it gets updated and it automates this process for you. Under the workflow, number of reports here. You can pick a report, design wire list. You can view the report. All the reports are generated and then they can be saved off as well. Again, automatically done for you. And comparing this to the traditional method, where we capture the lines and circles and then you have to manually put the bill of material together, huge time saver. So that's what I wanted to highlight here. If you need a custom report, there's a report builder there as well. So let me just close this project down, and I want to show you how we create a new project. See how quickly we can do that. So I'm going a new design. So I'm going to do in this project a new wiring design, and I'll just kind of go with the defaults here. My design. Notice the red. That's indicating that I already have a design with that name, so I need to change the number. It makes it unique. That's part of the design rule checking that's going on. And we can automatically create a diagram. Let me just do that real quickly in the interest of time. And now we've created a new design called My Design 4. Now notice down in the design browser, we don't see any plus marks in front of those folders, but the software has created the organization for us. So as we add components in our diagram, that'll begin to fill in. One of the things that you'll enjoy is the fact that we can create title blocks customized for your company. Here you can put your company logo in it. And this particular title block has smart properties in there. So you can decide what is the syntax you want to put for the name of the particular drawing, right? And where do you put that in your title block? We can count the sheets. This could say sheet 3 of 10 and so on, when it was created. Who was it created by? Was it reviewed? So all of these standards that you'd like to do, that you're doing today, we can automate that. And this is controlled through the style settings. Very powerful feature in here. So how do we create a new circuit? Let's do one of those together. And I'm going to begin down here in the design view by looking at the symbols. Here's the symbol view into the starter library, or also libraries that your team will add. But I can pick a particular library and I can navigate through it. Again, this would be your names, how you want to organize it. And I'll just pick batteries, for example. When I select on a symbol, it shows me what it looks like. So is that the one I want? Or maybe I want something different. Double click that, and then I can place that into my drawing area here. And another way to do this is actually look at the filters. So I'm going to go into the filters here and say, I'm looking for a switch, for example. So as I type switch, it's showing me all the library components where I can find a particular switch. So let me go down here. I'm going to use a simple switch here, double click, put that in there. I can zoom in so you can see it a little bit better. Same thing with the lamp. We add a lamp. And then chassis grounds, and then we're good to go. And here I can do Control C, and then I can do Control V to paste it. So essentially I put down those components. If I look at my design browser now, we can see that I have 4 devices in there. And then what we need to do now is add some wires. So all the commands are up at the top, and there's shortcut commands. Here I'm just adding a wire. And again, as I'm doing this, the wires are named automatically. I'll zoom in so you can see that a little bit better. Just adding the wires. Also, I have the routing set on, so it's aware that I want right angle routing. If I want to move this around, it's familiar with the behavior. We'll talk more about that later. Now on the left-hand side of my design browser, we see in the conductors, I have the wire names. So what you may want to do is say, look, I don't like the names of this. I want to go with wire 1 and so on, wire 2. Right, they need to be unique. So if I went over here and I forgot where I was in my numbering, if I went to wire 2, again, notice the red. It's indicating, hey, Mike, you can't do that. You got to pick a different wire, something like that. Also with the devices themselves, probably don't like that name. So look, I'm going to call this battery. And again, what I'm doing is I'm just working with symbols here now. Notice in this field here, there are no parts. It's just a symbol, and I'm capturing my logic here as I'm wiring this thing up. We go over here and then lamp. Now with lamp, for example, let's say I do want to add a part to this. Here's where I go to the library field, and then in here I can do a query. So this is going to be a query into the centralized electrical parts library. Our entire team would be pointing to the same library because we want to make sure the information is accurate. And now I can do this query here. Let me just click it real quick. And what it was showing on it had these default filters here. Show me all the symbols that equal lamp, right? And then it came back and it said there's 2 of them. I can take this filter and I can remove it. And I said, you know what? I want to add a different filter. And so I'm adding one, and now I have these parameters I can search through for the library. Color code, material code. Your team gets to fill in the data for this however you think it's most helpful. I'm going to go with description, and let's do something that says, show me everything that contains in the description, something called lamp. And let's see what we get there. So now we have more to choose from. So this is a way of narrowing down for the users to query into the centralized library what's in there that I can use. So if I want this one, I just double click this, and it actually made the assignment to the lamp. So that was just a real quick way to kind of show you how you create a circuit real quick. Let me just move these in so we can see a little bit better. And once I have that built up, I'm actually ready to simulate. So down in my design view here, I can hit analysis. And now we have the cyan. And you may recall from the presentation, what does a cyan mean? It means that we don't have current flowing through that. And because this is a functional simulator, I can hover over the switch. And so the switch is open. So what happens when I close it? Again, this is a pretty simple little design. Hey, I'm getting the green current flowing through that, just like I expected that to happen. If I want to look at the details of the current and the voltage, I can run a numeric simulation and then hover over the wire. And doing so, it actually gives me the current reading through the wire. So the point being here from the presentation, right, I captured my wiring logic together, and I don't have to do any additional graphics or editing to be able to run the simulation for that. Now, this is a pretty little simple case. Let me show you something a little bit more sophisticated, and then we'll move on to the next item here. Here's a more detailed circuit, same thing. I just hit the analysis tab, do the scope, and I'm ready to run. Notice the green and the cyan, same kind of thing. And here's again the switch. It's like, hey, I just want to confirm when I move this to position 2, is that the behavior that I was looking to get, right? So this can really avoid a lot of issues with the behavior of the circuitry long before you build the product. I did mention the design rule checks that are running in the background all the time. If I want to see what those checks are doing, I can hit the checks tab here. And here's 2 messages that I got. One of them saying that I have a wire that hasn't been terminated on either end. And what I can do is click this, and then it will take me into that part of the design where we found it. And what I did was I had created a new sheet in that design, and I put a wire in there. I didn't connect it to anything. So again, this is going to help you find where you missed something with your logic. It's not connected properly. That's called design rule checking, and it's running in the background for you. Okay, so that was simulation. And what I'd like to do now is show an example, because I've been selecting symbols from your library or parts from your library. What I want to show you is what can we do when you don't have symbols and you're still building up your library? Well, we can use things called devices. And devices allow you to wire up your schematic and diagram, make some progress while you're still working on the symbols, or you haven't decided what you want that symbol or new part to look like. So under devices here, I just simply come over here and I draw a device. And notice in my design, it actually shows my devices here. I'm going to narrow the view so we're just looking at this active sheet. Okay, so it just shows that one device. And if I want to add pins, I can do that here, and I just have to place where do I want the pins. And I can just do something real simple like this. Put those 5 pins down. If I'm done there, I can go with that. Or maybe I want to resize this. So what's really nice about this is, again, I don't need the parts or the symbols in my library to begin wiring this up. If I want to go back and say I need to add more pins there, I just go here. I can even make it longer by selecting the area here as well. So it's a really powerful way of doing that. Sometimes you'll have a device that has lots of pins. So in that case, right, we'll do this a little bit differently. In that case, it made put all these pins down in this new device. If I go and look at the device over here in the design browser, I can see all the pins here. I can highlight them. If I want to remove some of them from here, I can do that as well. Really a very flexible environment. And for wiring, I showed an example how to run some wires. If I need another pin on this particular device here, I can run a wire, double click. It actually adds the pin too as I'm wiring up the wires. And then I can undo. Here's a nice feature called multiple wires. Say I want to take all of these here and I want to wire them up over here. So now I automatically ran several wires. Again, depending on how you want to do this, I can rename these wires. And the tool is smart enough. Again, it knows these are wires. It doesn't want them to cross and things like that. So you can move things around. This is really important when you're first getting your arms around that particular initial drawing. One more thing, we have something called slice, or maybe sometimes the part is so big you want to fit it on another page. You can see if I zoom in here, this little lightning bolt type figure is saying that this particular device is the same device, but we broke it into 2 logical components. So again, depending on the type of design, this could really be pretty powerful. Let me do a highway really quick, and then I want to get into the connected mode, looking at the time that we have left. In a wiring diagram, sometimes you have lots of wires going around the page, and you want to clean that up. You want to get that white space back. Well, we can do that with a highway, which is a bus for some of you. All right, let me just show you how we can quickly create something like that called a highway. I'll do this quick and show you. So there was a highway that was created, and when I say, look, I want to take all of these wires here and I want to route them into the highway and clean that up. So now I have this real nice clean view. Logically, it's doing the same thing and allows me to view that. If I want to know what's in the highway, I can go in here and look at the view the usage. So it actually shows me what's in the highway. Sometimes you may want to pull out a particular wire. Let's take this one because it's a special wire, right? We want to select it, and then we're going to unroute it. And why would we do that? Well, maybe it's a control signal or something like that. We're going to rename it and call it control or whatever. But it just makes it more readable that this is actually going to control access into these devices or something like that. So the gist of this is a very powerful drawing application to get your wiring diagram. Make sure that you can find the information pulling from electrical parts library. So what I showed you there with the Solid Edge wiring design is how we can manage the data there. And for those of you that are using Teamcenter, we integrate with Teamcenter with the Solid Edge wiring and harness design. And you could see with the electrical parts library that was provided, how we can query into that and pull out the symbols and parts that you want your entire team using and sharing. We have styling in order to make sure that your company drawing standards can be followed by everyone. There's design rule checking in there to help you with your electronic connectivity associated with your design. There's simulation in there for both functional simulation as well as the performance of the current and the voltage. And it's very important to have the outputs from both wiring design and harness design, and we can generate multiple outputs. PDF is quite common and it's searchable. So I'd like to encourage anyone who wants to take this for a test drive, reach out to your OnePLM team. We have a free 30-day trial. You can find out more information from them. I can help with that discussion. If you're ready to buy it, right, you can buy just Solid Edge wire design, or you can buy Solid Edge harness design independently. Most buy both. It's the same software, one software install, but your license will dictate whether you have access to both of those. And what I focused on today was the Solid Edge wiring design. So here's my contact information on LinkedIn, and you should be able to connect with me. I'd be happy to connect. And the last thing here is I want to thank everybody for the time today. I know the hour went quickly, but the goal and objective was to introduce you to Solid Edge wiring design, show you why customers use it and how it can help you with that new methodology as you're adding more and more electronics into your products moving forward. So with that, Michael, I'm going to pass the ball back to you to wrap up for us.
Thank you very much for that, Mike. I hope you all found that interesting and useful. Now, before we close the webinar today, I'd like to spend the next minute of time or so quickly running through some of the ways that we at OnePLM can actually offer assistance with learning more about this module from here on. The first way is through technical screen share meetings or demonstrations online. And this is really where we set a meeting up with yourselves and we can either delve deeply into a certain element you may have seen on today's webinar, or answer any questions live, showing you how the module can be used to get around any issues you may think of. The second way is through a free 30-day trial of the module where you can get hands-on and start experimenting with this module. And I should also state that our technical team are on support with the free trial. So if you do run into any hurdles or stumbling blocks within that period of time, rest assured our team are on standby to jump in there and help you make the most of that period of time. Furthermore, we'll be in contact post-webinar to answer any questions you have, but also to find out more about your experience today, which leads me nicely on to the 2-minute survey. You will receive an email from us with a link to a 2-minute survey. It really does just take 2 minutes, and most of it is multiple choice. And the reason for that is we plan to do a lot more webinars in the future, and to get better and improve over time, we would like to have any feedback you can provide us with, not only about the content, but also about the entire setup and the whole experience you've had, just to ensure we work towards getting the best possible content for yourselves in the future. Thank you very much again for tuning in with us. As you can see, our contact details are on the screen if you'd like to contact us directly, and we hope you've had a good afternoon with us, and we will be in contact. Take care for now, and all the best.